Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to create the PID control by using the TIA Portal version 16 and use the PLC S7-300 CPU314C-2PN/DP. Okay. So if we talk about the PID, we must have set point and feedback and output, right? So if we would like to set point, example the temperature, so it will got feedback the temperature, and then the temperature will it means that the output will control the damper or valve or another devices to follow the feedback control. Okay, and we have some parameter like the gain, TI, TD, yes, something to adjust the PID to make the process bit smooth. Okay, so it is just the concept, and here is the block, the PID that we will create. Yes, and we also have the train for see the set point, feedback and output that we would like to view. Okay, so I will detail when we go to create the project for the PID. Yes, so now let's go to our project that we will use the existing project that we already learned about how to scale the analog input and output in the previous lesson. Okay, so now let's go to open TIA Portal version 16, and I will go with the slow step by step about how to create the PID block. Actually, the library, when we install the TIA Portal, we will got the blocks already, so we can drag and drop the block to use. Then we can control the process. Okay, so let's open the existing project. So wait a moment for opening the project. Okay, and then go to project view. Wait a moment for open. Yes, and we will go to see the existing block that we already created in the previous lesson. Okay, so in the previous lesson we already learned how to scale input and scale output, right? And also simulation with the HMI panel. Yes, and if we have the scale input and output, so we can create the new for the PID control. Yeah, example create PID control process. Okay, so to insert the PID control, first step, let's go to instruction. Yes, and then go to the PID control, and then go to basic function. We will got any blocks that we can use. Yeah, normally we can use the different block that we can choose. Yeah, many block, yeah, of PID. Yes, so right now I will choose control continuously control here, so drag and drop. Okay, we will got the PID example PID1 control. Okay, and then click OK. We will got the block like this. Yeah. So this one we can see here is the example that TIA Portal put for us here. We have Setpoint, PV peripheral, yes, menu, yes, TITD, yes, and many parameters that we can use. Yeah. So the same as my slide that I already showed, we have PV, we have Setpoint, PV, and output, right? So the first we need to enable or disable the manual auto, right? Yes, I will show a slide that we have here. Yeah, we have manual, yeah, deselect something, and then we will create the screen for simulation also. Yes, so first I will choose the nominal open example M20 or M60.100.0. It is the enable man on, right? Okay, and then let's see here we have deselect, yes, so deselect I will use nominal close example M100.1. Then I will rename the text as deselect. And then we have the cycle, right? This one I will put T 110 millisecond. Actually we can use 1 second or something, yes, that we want. Okay, I will change to 1 second, the same as default. Yeah, and here is the set point value. Yeah, so it is the real value, so we can use MD example MD28 we already used, right? So 32. It is the PID set point, and we will have the PV, right? PV in. So PV in we can use from the signal. Example, we use this signal for PV in. Yeah. So MD MD10, yes, we already learned, yeah, because example temperature number 1, so we can use MD 10. Temperature 1, yes, because we need to control the temperatures. And for gain, we can use PID1 underscore CTL dot gain, yes. Okay, I will change this one a little bit for PV. For PV, we can use 100, right? This one is from the analog. Okay, we'll generate here. And then this one we can change to be PID1 underscore CTL dot PV, yes. So when the input come here, example 150 degrees Celsius, it is the scale, so it will generate here, and then here we can use PID1 underscore CTL dot PV also, right? It is the PV. And for the TI TD, yeah, we can use PID1 dot underscore CTL dot TI, yes. And TD also PID1 underscore CTL dot TD, PID1 underscore CTL dot MT, yes. So for the output, we can use this one, right? It is the real. For output, it is the real. So we can use MD 32, 34, right? 32 MD 38. Sorry, 38. MD 38. It is the output, right? Output of PID. PID output. Yes. So it will generate from 0 to 100% here, and then we can take this one to analog, right? Because we need to use the analog, so we can change here, yes. So this one I will change to MD 38, yes. So when the set point here, it will generate the output, and then output will convert from 0 to 100% and go to the output milliamp, right? For control the damper or some the electrical devices, yes. So let's save the project, and then we can download to the PLC. Okay, wait a moment for communication between my PC and PLC, and then we will download. Okay, consider to download. And then we can go online to see the status. Okay. So right now the output is 0, right? So we will revise the touch screen a little bit. Example, set point and feedback, right? Okay. So first we need to have the set point, right? So MD32. So let's go to our HMI. Let's see right now around 74 degrees Celsius. Okay, because the input is here. I already connect the standard source loop milliamp to here. Okay, so PV it show. So we will go to create the text more on the HMI text. Go to HMI tab and then go to the HMI text. And we will create the new tag, right, for PID set point. Yeah, we have set point. It is the real, right, for data type. And it is the text of PLC, so we will select PLC. And the address is, let's see the address here, MD32, right? So we can select with MD32. Yes. And we have PV, right? So PV, it is the sensor number 1. Yeah, here. Sensor number 1. Or we can write PV or feedback PID, right? So we can use feedback is db1.dbd92, right? Okay. So address is db1 dbd92, right? Okay. And next step, let's go to add the output, right? So output here from 0 to 100%, or we can use the 4 to 20 milliamp here. Yes, because we convert already. So example, I will show as the percent. So we can use MD30H. So this one should be a PV as a percent, right? PV as percentage. So this one, it is the real also, MD30H. So I will choose MD30H, right? And the next step we have the timer for tune the PID, right? So for the timer we can use this one. The first one is gain, the second one is TI, TD and TM ALG, right? So first is gain. So PID gain. And then this one is db1.dbd20. So we can use db1 dbd20. Yes. And the next step is TI, right? TI db1.dbd24. So PID TI, okay, automatically. And then PID TD, PID T, TM ALG, right? Address is correct, 32, yes, it is correct. So the data type should be time, right, for this. So I will change to time for TD, TI, it is the time. Because we need to set the time like 5 seconds or 2 seconds or millisecond, yeah, something like that. And we have more for enable the selection, right? The first one is man on, yes. So M100.0. So PID man on. It is the boolean, right? So boolean and %M 100, right? .0. And the next step we will create deselect. So PID deselect, yes, 100.1, yeah, %M. And then we can save the project and then go to the HMI, right? In this step I will create one more screen because the existing screen already full here. Yes, it already full, so I will create one more, add one more screen for PID. So we can rename as PID screen. Okay, and then we can use, yeah. So the first one is Setpoint, right? So let me open the toolbox. Okay, Setpoint. Actually we can copy the text box from the root screen we already learned in the previous video. Copy the text and some unit here, yeah, copy, and then go to paste on the new page here. And for this page we can go to property and then we can change the background, this color, yeah, to be the same the PID screen, sorry, the root screen, yes. And this one should be set point value, right? PID set point value. Yes. So example, we set 200 or 100 degrees Celsius. So we can set point. And we have feedback, right? So I will put here example for PID control using TIA Portal version 16. Okay. I will change to yellow color. Yes. So this one is set point, and then we have another one for feedback, right? Feedback temperature. This one is feedback from sensor. Yes, feedback from sensor. So we have the feedback, right? Can copy first. If you can cancel and then copy this one. Control C, Control V. Okay. And we have output, right? Output. Example 10% or 50%. Yeah. So we have output. We can copy output value. Output value. It is the percentage, right? The value is percentage. Then we can show as the milliamp also, right? The same as the previous video. So this one output with the percentage, and we have one more for output with the milliamp, right? So we can copy. And this one we can write as milliamp to control the damper or VFD something. Yes. And I will adjust a bit because we have another parameters also to adjust the PID. Okay, so we have TID, right? Gain. So I will put gain here. I will adjust to be small, a bit small. So here gain and TI TD and one more right? So this one I will copy as gain, and we will adjust together. Then we have TI, right? TD, GM, LAG, right? So the unit is millisecond. So I will put millisec here. Okay, millisec also. And this one maybe I adjust a bit to be the same as the format. Okay, millisec. Okay, I will save first. And then for this tab, maybe I will put here it is the PID parameter, right? So this one should be PID parameter yes, PID parameters. So we can save the project and then we can adjust. Okay, we adjust a bit. And we can add the text, right? So the first one is Setpoint, so it is the input. And we will use the tag, go to the text. So PID Setpoint here. It is the input, right? Yes. And for the format is like this. And for the feedback, we can use PID feedback. Yes. Feedback of PID, yes, here. And it is the output, right? So we can choose output. Okay. And for the output value, it is the percent, right? So we can choose output also. And then we can choose output, right? PID output. PID output we already created, right? Feedback output. Oh, why not see the output? We not yet create the text, right? So let's go to check the text. PID output. PID output is MD38, right? MD38, let's check here. Already created, right? PV percent, yes, so we can choose the PV percent. So PV percentage here, and it is the output. Okay, so percentage, it is the output. Okay, and for milliamp output, we can choose the existing text here. Yes, MD28, right? So let's check the text. MD28 we already learned in the previous lesson. MD28 here, analog raw 1, right? So we can go to analog raw 1. It is the output also, right? Go to analog raw 1 here, and we can edit, right? Because we need to edit the text 0 to 22,648 on the PLC. So the HMI will show only 4 to 20 milliamp. Okay, so that's correct. And next we will choose the gain, right? So PID gain, right here, and it is the input, and the format I will choose another format because it is the time, right? So this one I will choose this number first, and for the TI, let's see the TI, and I will choose the input for TI, and for the format is maybe around here because we use millisecond. This one we can choose TD, and it is the input also, so we can choose input, and for the format we can also choose here. The last one is TM, right? PID TM, it is the input also, and the format I will choose the same. Okay, and we have also switch for enable, right? Here, switch for enable here, mains on and deselect, right? So let's go to add the button. We use the button here, PID main on, and we can copy, right? Can go to layout and then go to design, right? Actually we can put the okay, I will copy one more for deselect, right? PID deselect. Okay, PID deselect. So for this one, we can go to property and then go to event and choose the click, and we can use invert bit, right? So PID mains on, and one more we can choose also invert bit, PID deselect, right? Okay, okay, it's an example, but everyone can design the screen that everyone would like to design. Yes, so this one just example, so I will go to online. Maybe we can download the project to the PLC first. Okay, I will stop all because we just insert the new block of PID, right? And then start. And then go to see the blocks here. We can online. And then we can minimize some feature. So let me go to HMI and then simulation. Oh, we need to call the screen PID, right? Otherwise we cannot see because the load screen is the default screen here. So I can go to the screen to call the screen. So we can use one more button to call the screen, right? Example, call PID screen. Okay, I will put here first. Okay, and go to event, and then go to click and then activate screen, and activate the screen PID, right? Okay, screen PID screen, and we can copy this one to the PID screen, and then we can paste, and this one we can use as root screen, right? Okay, root screen, and then go to event, and then go click and activate the screen also, and activate the screen root screen. Okay, and then we can simulation again. Then go to see the PID blocks. Okay, so let's see here. Okay, I will minimize this one, and then here. Okay, so right now I will call the PID. Okay, this one root screen, right? Okay, call the PID screen. Maybe I will adjust this one a little bit for button, right? Should be like this. Root screen also, and then we can simulation again. Okay, I will call the screen PID. Yes, like this. Okay, so right now if I set point example, I set 100 degrees Celsius. Let's see, the milliamp is 20 milliamp and the output is 100%, right? But the time adjust is so fast, so I will adjust again to be example 1, and this one should be 5 seconds. Yeah, this one should be 5 seconds first. Yeah, for the first tuning. Yes, so the target that I want is 100 degrees Celsius, but the sensor is show only 74 degrees Celsius. So I will adjust the current loop. Let's see. I will adjust step by step, easy to understand. Okay. It's so fast again, right? So we need to adjust the T. Let's see here, it is the second, right? One second, 5 seconds, right? We can adjust to big for time, for easy to see. Yes. .5 for gain. So fast, right? So we can adjust the TI to be 10 seconds. Yeah. Let's see if we adjust the TI to be 10 seconds, and then let's see the value is changed so slow, right? So we can adjust the timer for tuning the PID. Let's see here. So if the temperature is okay, we adjust. Let's see right now the milliamp is show 20 milliamp, right? Because it is 100% and 20 milliamp also here. So if I adjust the current loop, let's see the milliamp is so fast, right? Adjust so fast. So we can adjust the gain. Yeah. Actually, PID we should sit and tune the signal to be smooth. So fast, right? Adjust so fast. So we can adjust some timer. Yes. It's so fast, right? Working so fast. So it's slower than before, right? If we adjust the timer. Okay, so we can adjust the timer. Yeah. Example, adjust 1 minute. Yeah, something. So let's see the value is adjust slowly. Yes, adjust slowly. And we can also see the trend. Yes, see the trend. You can see the trend also. Yes, we can online to monitor. And see the trend. Yes. I will adjust to be 1 second. Yes. And then for this one, we can adjust to be 0 to 150. And then we can monitor the set point in PV and output here. Yes. Example, I change the set point to be 55 degrees Celsius. Let's see it change, right? I will adjust the analog input. Yes, let's see it adjusts. The milliamp is adjust also. Okay, so we can adjust the time, yes, or gain to tune the PID. Yeah. Example, I set 0.1 gain. It faster than before for output, generate the output. Yes. And we can also see the trend here. Yes. Yes, it will working. Set point is 45. The PV is around 44 something. Let's see the output is generated around 75%. Yes. So if I adjust the PV to be bigger than, yes, set point, yes. Let's see the output is decrease, yeah, and trend is decrease also. Okay. So we can adjust the time that we want if we would like to control the process smoothly. And I will change the address this one a little bit. Yeah. Okay, so we can see and monitor and control the PIDs that we want. Okay. So this is just example. Yes. So I will change the address this one little bit because we cannot control right now. When I push here, it not work, right? Because M 100% we already use here. Yes. So we cannot control. I will change the address a little bit. I will change to be M 2.0. Enable main on, and this one I will change to M 2.1. Enable or deselect, right? Deselect, yes. And then I will change add the HMI also, HMI text. This one I will change to M2.0. This one M2.1, right? Then we can download to the PLC again, and we can online again. Let's simulation again. Okay, let's see, the button is working because the address is double or complete with the block on the top, right? Okay, so now we can control the button. Yes. So I will adjust the set point again. Example 45, and this one 0.1. This one 8,000, 80,000, 6,000, 5. Yes, it's just example because we can control it by timer. Yes, that we set. So example, I adjust the set point to be 120 degrees Celsius. Let's see, the PID is working, and adjust the output to be 100% because the PV is feedback only 48 degrees Celsius. So if I adjust the milliamp, let's see, the milliamp is show 20 milliamp, right? So if I adjust the PV, to be nearly 120, let's see, the output is decreased, yeah, followed by PV, and the milliamp is decreased also. So we can take this milliamp to control the control valve or damper or VFD something. We can use it. Okay. So it will working by timer and gain here that we can adjust to be process is smooth. Follow the PID trend here. Yes. So this is just example about how to create the PID for control the process, and we can adjust the parameter something. Yes. So we can apply to another process that we want to control by using the PID. Okay. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.